Hello, my name is Tom Holoien and I'm a graduate student in the Astronomy Department at The Ohio State University. I'm also a member of the All-Sky Automated Survey for Supernovae, or ASAS-SN, and today I'm going to tell you about our new paper titled the ASAS-SN Bright Supernova Catalog 3, 2016. This is the third in a yearly series of papers on bright supernovae and their host galaxies that will be written by the ASAS-SN team, and it contains analyses from our first 3.5 years of operation. This paper collects information on all supernovae discovered by ASAS-SN in 2016 and their host galaxies. As we did in our previous catalogs, we also collect the same information for all supernovae with peak magnitude of 17 or brighter that were discovered by other supernova searches in 2016. More details on the information collected and the sources of the data can be found in the paper or in the video for our first catalog, which is linked in the description below. We performed some simple analyses on the data we gathered, including results from our first two catalogs. To keep the samples consistent, these analyses include only those supernovae discovered after May 1st, 2014, when ASAS-SN became operational in the Southern Hemisphere, and only those with peak magnitude of 17 or brighter. This figure shows a breakdown by type of the ASAS-SN discoveries, the supernovae discovered by other observers, and the entire supernova sample for 2014, 2015, and 2016. The ASAS-SN sample continues to closely resemble an ideal magnitude limited sample as predicted by Lee et al. From the lost dataset, while the overall sample contains higher proportions of core collapse supernovae. ASAS-SN discoveries stand out clearly when looking at the distributions of their host galaxy magnitudes and their offsets from host galaxy nuclei. This figure shows a cumulative normalized histogram of absolute host galaxy KS band magnitude for ASAS-SN discoveries in red, other professional discoveries in blue, and amateur discoveries in black. Professional surveys, including ASAS-SN, clearly stand out from amateurs who tend to focus on brighter, nearby galaxies for their searches. This figure shows a cumulative histogram of supernova offset from host nucleus in arcseconds. ASAS-SN discoveries have a significantly lower median offset than either other professional discoveries or amateur discoveries, indicating that ASAS-SN is less biased against finding sources near the host nucleus than others. This is true when looking at the offset in kiloparsecs as well, where amateurs and other professionals actually have a very similar median offset. ASAS-SN's impact can also be seen when examining the number of bright supernovae discovered per month. This histogram shows the number of bright supernovae discovered each month from 2012 through 2016, with red representing ASAS-SN discoveries, yellow representing supernovae discovered by others but recovered in ASAS-SN data, and blue representing supernovae not recovered in our data. The pink dashed line shows the median number of bright supernovae discovered each month from 2010 through 2012. Since ASAS-SN became operational in the Southern Hemisphere in May of 2014, the number of discoveries has been above this median in every month, and the average number of discoveries has increased from 13 to 20. This implies that ASAS-SN finds supernovae that wouldn't be found otherwise. Finally, this figure shows a cumulative histogram of supernovae discovered at different peak magnitudes in our full sample. The red sample represents only ASAS-SN discoveries, the blue line represents ASAS-SN discoveries and supernovae recovered by ASAS-SN, and the black line represents all supernovae in the sample. The magenta line shows the expected number of supernovae in a Euclidean universe, while the green dashed line shows a broken power law with a Euclidean slope below the break magnitude and a variable slope for fainter magnitudes. The power law fit shows that our sample is complete to a magnitude of roughly 16.3, and that roughly 70% of supernovae brighter than 17th magnitude are being found. The analyses presented in this paper again highlight the fact that ASAS-SN is having a major impact on the discovery of bright supernovae. ASAS-SN remains the only professional survey to provide a complete, rapid cadence survey of the nearby universe, and in 2017 we will be expanding with new units in both hemispheres, allowing us to survey the entire visible sky every night. It is our hope that by collecting the data in these catalogs, we will provide convenient repositories, allowing for new and interesting population studies of nearby supernovae and their hosts. For more information on this work, or on the source of the data in the catalog, please see our paper which is posted on the archive. Thanks for watching.